Hello and welcome back, everyone. Thanks for joining OWASP AppSec Days India Virtual Edition. I'm your host, Karan Shah. Now, the upcoming session will be presented by Bala Kumar Subramani, whose topic will be with respect to leveraging DevSecOps and AI to triage and resolve the OWASP top 10 vulnerabilities in a project. Right? So I'll just add Bala to the stage. Hi, Bala.
Hi, Karan.
How are you doing?
Doing great. How are you?
All good, all good, all good. I'll add your slide deck as well. So, yep, the stage is all yours. Good luck.
Thanks, Karan. Good afternoon, everyone. So myself is Bala Kumar Subramani. I'm a senior software engineer at the security risk management team working at GitLab. Today, I'm going to speak on the topic leveraging DevSecOps and AI to triage and resolve WASP top 10 vulnerabilities in the projects. All right, let's move on. I'm going to split the talk into various sections. First up, we'll be covering DevOps review, what is WASP top 10, the overview of that. And then the next section will cover about security scanners and how to configure them in CI/CD pipelines. And then the reported vulnerabilities using AI. In the last section, I'll just had an FAQ for some of the most frequent questions that come up in this topic. So just moving on, going to the first section, it's about the switch from the DevOps to the DevSecOps that happened in last decade. So predominantly, like after 2015, before 2015, teams were like following the DevOps cycle. They were doing the planning, then going ahead and then doing the coding. Then they were like building the apps, doing a release deployment, and then they like monitor things and then test it out. Right, so that used to be the flow. And then when DevSecOps came into picture, teams identified that doing testing at the last stage is just not ideal. So why not we do that at every stage of this DevOps cycle so that vulnerabilities are caught as and when at the earliest. So before like development happened, operations and an application delivery happened. Then after all of that happened, the people were like doing security testing. And instead of that, they introduced another dimension of doing security testing in all the phases of a DevOps lifecycle. So introduce another circle and integration of all of that leads to better results. So that's the revolution. Let's see an overview of the OWASP top 10 list. As most of you are aware, WASP categorizes the top 10 most critical web application security risks. So the most recent one is 2021 and succeeding the 2017 list. And most of the security scanners that is currently available in the world follow these two conventions. So security scanners, they have like rule engines built on top of them. So this is an example of a rule where we see that an SQL injection vulnerability is being classified as WASP 2017 as well as an WASP 2021 injection type vulnerability. So this is an overview. It just simplifies a lot of effort as it prioritizes and gives a label and a category for the vulnerabilities. We will dive down. We'll dive into our first session, which is seeing how security scanners can be set up in a CI/CD pipeline. So just going back to that overview where security testing happened at the last phase, now we wanted to shift it towards the left and do the testing at each phase of the DevOps lifecycle. Right? So we'll start with the plan phase, So as part of the design and as well as the design implementation plan, we wanted to have a roadmap for the security analysis and the security test plan captured. And then once we go into the coding stage, we have the tools like linters and the Git hooks set up, which captures some of these code spells early on as and when the code is being produced. Then now when we move on to the next phase of building the application, there are like tools available, uh, tools like static scanners and SAS scanners. They can be configured. Then the next stage is test. This is where more advanced tools like DAST and the integration testing tools can be configured. Once when we go on to the release phase, we can run the penetration testing tools. And then once we go to deploy, we can leverage the ethical hackers and others to do the testing and report vulnerabilities. So OWASP has a good list of scanners that are available to do this job at various life cycle. So the link is there. We can figure out the best scanners there. And once we configure these CI/CD pipelines with the scanners, we get a feedback of the vulnerabilities at each and every stage instead of actually like waiting on the last stage before the release to know about the vulnerabilities for the new change that is going in a merge request or in a pull request. So how do we configure security scanners? Predominantly in today's world, most of these DevSecOps platforms do it in two ways, using YAML definitions or using a platform UI where users can go and configure and plug in the various scanners. So if you most of you might be already aware and you are doing this way where you're just defining a YAML language to configure a scanner. And then some of these platforms also give a UI where teams can go and enable the scanners that they want. The important step to remember here is to be aware of your application environment, where it is deployed, and the language of your application, so that the right scanners are configured. So that's about like configuring scanners. The next part is once you have configured a scanner for your pipeline and a merge request is happening or a commit has gone in, now your pipeline is running, your scanners are running. What next after the pipeline is running with the scanners, right? So next comes the reports that are generated by these scanners and how do we triage them. So that's the next section. In this section, most of the reports generated by the scanners are machine passable. They will be mostly JSONs. And if we are dealing with a single project or if someone is comfortable on command line, that might suffice. But otherwise, for a daily use case, it is very new, and we need an application platform which can read this JSON input and show us an actionable report to take actions. So that's where these platforms hold good. In this example, you see that we've configured a SAS scanner, and as part of the code diff, it smells this a problem with this code and reports it that there is a problem here. In this case, it is an hard-coded password. And this is the feedback widget that gets that comes in the UI of most of these platforms. This feedback widget understands the reports and then it lists the various vulnerabilities and the categorizations of these vulnerabilities, whether it is critical or severity or how what scanner detected it and stuff like that in a quick summary format. integrated into your change request or your merge request or your pull request. Now, once that happens, how do we do this for a lot of projects? Because in development groups, there will be like typically like hundreds of projects, or in an org, there will be like thousands of projects. Now, for each of these projects, if there are like many vulnerabilities is being reported, how do we take action, or how someone in the leadership org will know that this is the amount of vulnerabilities that is happening, being detected in the source code. So how do we do a compliance audit sort of a thing? So that's where platforms comes into play. So once the scanners are configured, the reports are generated, we need a good platform to view the reports. As I said, most of these scanners identify vulnerabilities metadata with the OWASP list A1 to A10, and we can leverage that and then group that using the existing OWASP categories to give a good overview of the vulnerabilities and where they belong. So this way we will get an idea of what is the top priority vulnerabilities that we have to fix it, what could be the least one. And this will be handy if there are like thousands of projects. So in this case, this particular platform is grouping the vulnerabilities belonging to that particular repository group by the worst top 10 2017, and it's categorizing from A1 2017 to the A8 in 2017. So this way we get an overall picture, as well as we know that this is the top priority vulnerability that has to be fixed, and a quick follow-up can be done. Right. Now we configure scanners. The scanners are generating the reports. We know how to understand and interpret these reports. Now, what comes next? How do we fix this vulnerabilities? So let's move on into that section. We're going to see how we remediate vulnerabilities using AI. So this is the new dimension that is getting added to DevSecOps in the last 2 to 3 years after the advent of the AI models, and it's really interesting, and we never know what the future holds after this as well. So AI-powered suggestions for remediations. The quick win here is most of our developers, what they do once they identify a vulnerability is they go to their favorite GPT interfaces, type the code saying that fine, there is this vulnerability, give me a quick fix for this, and then just copy paste solutions from there to their IDEs, and then go ahead and then submit the change request or a pull request. Now the problem is there is like too much of context which is happening. The modern DevSecOps platforms, they have the state-of-the-art models already integrated into the area where the vulnerabilities are being reported, and we can leverage that. And whatnot, some of these platforms even automate that entire process of creating the fix and submitting and merge request and a pull request with the fix for that vulnerability. So with this, the advantage is that developers can get a quick understanding of what the vulnerability is and do a quick fix instead of doing many context switches. This is an example of a vulnerability on one of these DevSecOps platforms where it is an A1 2017 injection type vulnerability WASP category. It is doing a bad thing. It is doing a string copy without doing any sanitization. So it leads to injections, and it is vulnerable with the buffer overflow. So what this platform does is that it gives an interface, and it actually like explains the vulnerability, why it is bad, and it also gives a fix for it, suggesting the alternate snippet that can be used. In this case, instead of doing a string copy, we do a string and copy, and we also limit the size of the input and append a /0 so that the buffer is not overflowed. And so this is, saves a lot of time. So imagine now a developer with being reported this bug, right? So they'll have to go to their code base, identify this line, get the context of the entire source file, and then figure out a solution. Now, if they can have this information handy right next to the interface where the vulnerability is reported, uh, along with the widget to actually like submit this proposal remediation as a pull request or a merge request, that saves a lot of time and increases productivity as well. So that is the kind of future that we are looking at. So how DevSecOps are evolving, where instead of now identifying the vulnerabilities, they are actually like proposing remediations as well. So that just covered the three sections that we discussed. We looked at scanners, how to configure scanners in your CI/CD pipelines, then how we actually like look at reports generated by those scanners, and once those vulnerabilities are identified, how we can go ahead and then use the AI integrations in these DevSecOps platforms to come up with fixes for these vulnerabilities. So that just covers the entire life cycle, and so this comes to the last topic of my talk, which is an FAQ. So which scanners to configure and at what stage? So that's an interesting question, because if we configure a wrong scanner at the wrong stage, then your pipelines may not be as optimized as productive, because if a lint problem has to be caught, and in that same stage, if you're already also running another task scanner parallelly, that leads to a lot of pipeline runtime wastage. So it's important to identify your stages in your application CI/CD environment, and then configure the right scanners. So this map gives a good overview. It's not like the Holy Grail book or the Bible, something like that. So it's predominantly what most of the organizations follow. So on the commit phase, we do most of the static analysis tool, and then on the build phase, we run the container scanning tools. At this phase, dynamic scanning and API security. On the deployment stage, the operational container scanning. So this is sort of the thumb rule that we can follow. How do we determine a good scanner for my application? Here as well, no hard rule. The common practices and the common parameters are to choose which one is community driven and has active contributions. And depending on the language and the framework of the application, just figure out the scanner which has the community engagement. Which AI models to use for vulnerability triaging? So these again, AI models are evolving. So from our experience, what we figured out was Anthropic Claude 3.5 Sonnet is performing best for vulnerability resolution, and the Claude 3 Haiku model is performing best for vulnerabilities explanation. So that just wrapped up my talk. We covered all the sections. So it's interesting how this entire field has evolved, where 10 years before we were following a DevOps model, and then how we integrated security into each of the DevOps model. We call it as DevSecOps. And now how we are using AI to propose solutions and fixes for vulnerabilities. And what comes up in the next future is really interesting, and it's really engaging, and looking forward to that. So just wraps up. Thanks for your time. And yeah, thank you. You can reach out to me on this email, and I'm also available on X.
Awesome. Thank you, Balakumar. This was an amazing session. So DevSecOps and AI has been in the trend since quite a lot of time. I mean, AI for remediating, and AI will change a lot of things in DevSecOps with the conventional DevSecOps that we see on a regular basis. So I'm sure your session will actually be very helpful, and there will be a lot of people who will be reaching out to you over your socials or through live chat, and I'm sure the questions will be answered surely. All right. Thank you everyone for joining in, and you've been a great audience. A big thanks to Google for sponsoring this event, and stay tuned for the next session. Bye-bye.